Let's examine the quadratic equation, open parentheses 3x minus 1, close parentheses squared, minus 25x squared equals 0. This is a special type of quadratic equation we can solve efficiently. Notice we have a binomial squared term, open parentheses 3x minus 1, close parentheses squared, highlighted in yellow. This structure gives us a hint that we might be able to use the difference of squares pattern. To solve this equation effectively, we'll follow these 4 key steps that apply to many quadratic equations with similar patterns. Step 1. We'll rearrange the equation to isolate the squared terms on opposite sides. Step 2. We'll recognize and factor the expression as a difference of squares, which is the pattern a squared minus b squared. Step 3. We'll use the formula that a squared minus b squared equals open parentheses a plus b close parentheses times open parentheses a minus b close parentheses. This is a fundamental algebraic identity. Step 4. Once we have the factored form, we can set each factor equal to 0 and solve for x. Now let's work through the actual solution process step by step. Here's our original equation. Open parentheses 3x minus 1 close parentheses squared minus 25x squared equals 0. First, we move all terms to one side. Adding 25x squared to both sides gives us open parentheses 3x minus 1 close parentheses squared equals 25x squared. Now we have a perfect setup for the difference of squares formula. Looking at this equation, we can identify that a equals open parentheses 3x minus 1 close parentheses and b equals 5x. Using the formula a squared minus b squared equals open parenthesis a plus b close parenthesis times open parentheses a minus b close parenthesis, we get open parenthesis 3x minus 1 plus 5x close parenthesis times open parenthesis 3x minus 1 minus 5x close parenthesis equals 0. Now let's simplify what's inside each set of parentheses. In the first factor, 3x minus 1 plus 5x becomes 8x minus 1. In the second factor, 3x minus 1 minus 5x simplifies to negative 2x minus 1. So our equation becomes open parentheses 8x minus 1 close parentheses times open parentheses negative 2x minus 1 close parentheses equals 0. What we've just applied is the difference of squares pattern. It's a powerful technique that allows us to factor expressions in the form a squared minus b squared, which otherwise might seem challenging to solve. When a product equals 0, at least one of the factors must equal 0. So we have 8x minus 1 equals 0, or negative 2x